So now we have a way to measure how bad a line is. The final question is, how do we change the line to make this number smaller? In the previous scene, we calculated something called mean squared error. This number tells us how bad a line is. Smaller number means better predictions. Now here's the big idea. Every straight line we can draw has its own MSE. When we change M, the line tilts. When we change B, the line moves up or down. So by changing M and B, we can draw every possible straight line. Our job is to find the one line that gives the lowest MSE. The best line does not mean it passes through all points. It means, on average, it makes the smallest mistakes. That's what MSE measures. In theory, we could try every possible line. Change M, calculate MSE. Change B, calculate MSE. Repeat forever. But there are infinitely many lines. So we need a smarter way. Instead of jumping randomly, we improve the line step by step. We start with a guess. Then we slightly adjust the line. If MSE goes down, good. If MSE goes up, bad. This is what learning means in machine learning. Not magic, not guessing, just repeatedly changing M and B to reduce MSE. The only question left is, how do we know which direction to change M and B? That's where gradients come in. So we need direction, not just movement. Gradient means which way makes MSE go down fastest. Gradients tell us how to change M and B. This is how learning becomes systematic, not trial and error. In the last scene, we said our goal is simple. Change M and B so that MSE becomes smaller. But there's a problem. When we move the line, there are many directions we could move it. We could try guessing. Change the line a little, recalculate MSE. If it gets worse, undo it. But that would be slow and unreliable. We need a rule. Think about standing on a hill. If you take one step in different directions, some steps go down and some go up. What we want is the direction that goes down the fastest. The gradient is just a direction. It tells us which way MSE increases the fastest. So if we go in the opposite direction, MSE decreases the fastest. Remember, our line is controlled by M and B. So the gradient tells us two things. How should we change M and how should we change B? Mathematically, we calculate two gradients. One tells us how MSE changes when M changes. The other tells us how MSE changes when B changes. You don't need to memorize these formulas. Now the process becomes very clear. Calculate the gradients, move M and B slightly in the opposite direction, recalculate MSE, repeat. This is why machine learning scales. The same idea works with 2 parameters or 2 million. Gradients tell the model exactly how to improve. In the next scene, we'll actually calculate one gradient step with real numbers and see the math behind it, so you can see learning happen on paper. We will pick actual values of M and B, calculate gradients, update them, watch MSE drop. We always start with a guess. It doesn't have to be good. It just has to be a starting point. Let's say m is equal to 0 and b is equal to 0. Plot the data points. Draw the prediction line. Use this line to make predictions. For each x value, we plug it into the equation. Whatever comes out is the predicted value. Now we compare prediction with reality. Error is just actual minus predicted. Now we square the errors, add them up, and take the average. That gives us MSE. Now comes the gradient. This tells us how to change M and B. We'll calculate two numbers. Now we update the line. We move in the opposite direction of the gradient, using a small step size. This gives us a new line. Same data, better position. Now we do the same thing again. Make predictions, calculate errors, calculate MSE. Nothing magical happened. We didn't guess. We followed the math, and the line got better. This is one step of gradient descent. Training just means repeating this again and again. If you want to get your hands dirty with the math we just covered, I've made the entire gradient descent script available for you. You can find the source code on my GitHub, or if you want to run it right now without installing anything, just click the Google Colab link. It's pre-configured with the data table we used today, so you can hit play and watch the MSE drop in real time.